Hey everybody, quick video that answers that question that I got stuck on in class last time about why the equivalence classes partition the set A. Remember, basically what that means is if we have our set A and we start to group everything by their equivalence classes, then everything is part of one and only one set. Okay, so we're going to do that in two steps. We're going to show that first, if A is equivalent to B, then the equivalence class of A is equal to the equivalence class of B. And then we'll use that to show that if two equivalence classes are not disjoint, they have to be the same. So what that means is you'll start by choosing points in your set A, and they have to be in some set, but what we need to make sure is that those sets that those sets partition the set A, that is, they each element is in one and exactly one set. Okay, so quickly, to show that if A is equivalent to B, then the equivalence classes are the same. Well, what we'll do is we'll show that the equivalence class of A is a subset of the equivalence class of B, and the equivalence class of B is a subset of the equivalence class of A. And if those two things are true, then they're actually equal as sets. Alright, so how to show that it's a subset? Well, we'll choose some element, let X be in the equivalence class of A. What we'll do is we'll show it's in the equivalence class of B. Well, if X is in the equivalence class of A, then X is equivalent to A. But part of the assumption is that A is equivalent to B. So we have X is equivalent to A, and X is equivalent to B. Sorry, and A is equivalent to B. So by transitivity, X is equivalent to B. And if X is equivalent to B, then that means that X is in the equivalence class of B. So that's great. Now we know that anything that's in the equivalence class of A is also in the equivalence class of B. So the equivalence class of A is a subset of the equivalence class of B. The argument works just fine the other way. So if we were to say let Y be in the equivalence class of B, then that means that Y is equivalent to B. Again, we use that A is equivalent to B. And so now we have A is equivalent to B, or Y is equivalent to B, and A is equivalent to B, so A is equivalent, so Y is equivalent to A. So Y is in the equivalence class of A. Alright, so that means we now know that this first point is good. So now let's prove this other part. So if two equivalence classes are not disjoint, they are the same. So if they're not disjoint, then, so if E of A and the equivalence class of A and the equivalence class of B are not disjoint, then there's something in both of them. Then there is some element C in both of them. C is in the equivalence class of A, and C is in the equivalence class of B. Okay, well, what does that mean? Then C is equivalent to A, and C is equivalent to B. Again, by transitivity, this means that A is equivalent to B, and now we can use our point from before to say, therefore, E of A, equivalence class of A, is equal to the equivalence class of B, and that's what we needed to show. So that's saying that every element is in one and only one equivalence class, so they partition the whole set. All right, thanks for listening. Talk to you later. Bye.